Exercise 22. An ellipse touches the sides A, B, B, C, C, D, and D of the parallelogram A, B, C, D of points P, Q, R, S respectively. Prove that CQ over QB equals CR over BP. Sorry, just went over that quickly to save some time. So that's what we're showing. We have an ellipse E inside our parallelogram with points labelled respectively, and we're proving this. And so the first step will be that we know that there is an affine transformation that changes an ellipse into unit circle centered 0, or a circle centered 0, with corresponding points, A dash, B dash, from A, B, P goes to P dash, and so on. And we also know theorem 1.16 that after an affine transformation, it proves that these tangents going from here to here are they're still tangents pretty much. That's what that theorem proves. So the affine transformation on E goes to E dash. Ellipse goes to a circle. And since ratio and lengths are preserved in an affine transformation, S naught will be equivalent to S dash naught dash. S dash naught dash will be equal to naught dash Q dash because it's the center of this. This will be equal to this. So that's what we're going to say. Let's call it A. This will be A. This will be A. And that's summed up here. Similar for B. B is this. And since we have this equals A, this equals A, so SQ will be 2A, shown here. And since parallel lines are preserved, SQ will be equal to DC or AB, shown here is 2A. So now we have SQ equals DC AB. These are all 2A. And since these points are midpoints, we know that this will also be A respectively, which will be shown here. And we get, therefore, CR over BP equals A over A equals 1. And by the same argument, I have another diagram here. So I need, by the same argument, R naught equals B, which is R naught will be B. This will be B. And since parallel lines are preserved, these will all equal 2B, same as the argument for A. And that's shown here. R naught equals B, so then R naught equals B, so then RP will equal 2B. And as RP is parallel to CB, similar to the A argument, that will equal 2B, which leads to this ratio, similar to the A, equaling 1. And since ratios are preserved in affine transformations, we know that C dash R dash over B dash P dash will be equivalent to CR over BP, and that equaled 1. Similarly, C dash Q dash over Q dash B dash will be equivalent to CQ over QB because it's an affine transformation, ratios are preserved. So we know they will both still equal 1, leading to our final argument.